I'm Jang from Korean Soft in South Korea, and it's a great pleasure to be here and listening to the wonderful lectures and insights. So my title is From Variability to Reliability, and I'll keep it the time exactly. So let's go. So as all we are aware, lung cancer screening is a growing global priority and trend. So as we know that there is a lot of nations that do the lung cancer screening pilot projects as well as national projects. So these are the representative pilot and national projects of lung cancer screening, and we are doing our best to do the reference of the software platform across the international SDS programs and like standardization and harmonized reporting. So our moat, I have to say it's a moat, is a concordance rate with the radiologist. So we detect the nodule, we analyze the nodule, and we report the nodule as the radiologist do. So we are very compatible with the radiologist I have to say. And but the problem is that there is a lot of protocol and like real world problems that can make lung cancer screening heterogeneous. So the first is that the slide thickness. The second is the kernel convolutional kernel. So there's a lot of problems for the homogeneity of the lung cancer screening. So FDA released the Cancer Imaging Archive, nodule phantom and lung phantom, artery phantom. So we compared the two algorithms. First is our previous algorithm. Second is our AI algorithm. So we use the computer vision, classic computer vision tool to segment the nodule, and now we are doing by AI. As you can see, the first version 1 is like very variable. But the second one, the AV segmentation, version 3 is more stable and robust. And for the other solid phantom nodules, the trend is the same, and the standard deviation of the volume is much more higher, like 1 in a fifth. For the GGM phantom nodules, the computer vision segmented a little bit larger, but the AI segmented very stably and robustly. For this is another case. So in some cases, it over segments, in some cases it under segments, but AI is much more stable, and it is, as you can see in the left AView for seg V1, AView seg 3, the true volume is much more accurate compared to the computer vision derived segmentation algorithm. So it's the overall result for the all nodule analysis except one which is very large. So compared to the left one, version 1, the version 3 AI algorithm is much more stable, less variable. So is it all? But we have discussed this morning about the CAC and LAA, the emphysema things as well. So if you take a CAC analysis like over some threshold for the LDCT segmented lung, you can see that the left upper side, there is a lot of false positives compared to the down one, which is kernel adaptation by AI. So we can convert the sharp kernel to a little bit softer kernel, and we can segment the coronary artery calcium very accurately. And it is not, of course, it is not 100% because there may be motion artifact and other like LDCT problems, but it can act as a screening method to, you have to do the cardiac gated CT. And for the LAA analysis, it's the same. The small noises, like fluctuating noises, make the LAA segmentation very weird, but with the kernel adaptation, it becomes stable, and you can see that the result is much more better in the write-down image. So, but even with the kernel adaptation, there may be some kind of noises that has been left. So we provide the size analysis as well. So you can see that the clusters are segmented in different color-coded clusters. So you can say that, oh, the very small ones are just noise, and the larger ones are that are meaningful. So yeah. So I ended up a little bit earlier than we planned, and our slogan is from variability to reliability. So I made a punchline sentence: variability is inevitable and instability is evitable. Thank you.